If I'm going in the opposite direction, it's actually pretty simple. If I want to represent a number like 3 as a square root, then 3 is the same as the square root of 3 times 3. Or 3 is the same as the square root of 3 squared, because these are opposite processes, square root and squared. So if I want to move a 3 from the outside inside, then I'm going to first square the 3, and then say that 3 squared is the same as 9, and multiply that by the 14. Which means that I'm going to have the square root of 126. So if I want to turn these mixed radicals into entire radicals, then 2 root 5 is the same as the square root of 2 times 2 times 5. 4 root 7 is the same as the square root of 4 times 4 times 7. And 10 root 6 is the same as square root of 10 times 10 times 6. The first one is going to give me a value of 20. The second one, where I take 4 times 4 times 7, it's going to give me a value of 112. And the last one is going to give me a value of 600. If I'm doing the same with fractions, then I'm just going to multiply the numerator and the denominator, which means that this would be the same as the square root of 3 over 2 times 3 over 2 times 8 is the same as 8 over 1. And then I just multiply straight across the numerator and straight across the denominator. So 3 times 3 times 8 is going to give me 72. And 2 times 2 times 1 is the same as 4. And then I can still take a look at it and say, well, can I reduce this? 72 divided by 4, yes, it does divide out evenly, and I can just call it the square root of 18. It's a mixed radical, but it's been simplified. If I'm taking one like 0.4 and the square root of 50, first thing I'm going to do is I'm going to turn that 0.4 into a fraction. You can just put in 0.4 math frac if you're not sure how to turn it into a fraction, and that's the same as 2 over 5. Which means that this would be the equivalent of 2 over 5 times 2 over 5 times 50 over 1. And this is going to give me the square root of 200 over 25. 200 over 25 is the same as the square root of 8. One thing I have to be careful of is if I have negative in the coefficient. If it is a odd index, I can move it inside. But if it's a positive index or an even index, it doesn't work. I can't move a negative inside of a radical. So this means that it's anytime it is a negative coefficient, it is not going to be the principal square root. So when I move this in, I can still move the 5 in and say that it's going to be the square root of 5 times 5 times 7, but the negative has to stay on the outside, and I can't drop the negative, otherwise it's not an equivalent value. So this would be the same as the negative and then the square root of 175. If it's an even index, leave the negative on the outside. If I need to arrange mixed radicals from least to greatest, it's hard to tell if they're mixed radicals, but if I turn them into entire radicals, then I can tell right away which is the biggest and which is the smallest. If I take for the first one 3 times 3 times 5, then I'm going to get the square root of 45. If I took 5 times 5 times 3, I get the square root of 75. This one will just stay the square root of 15. 2 times 2 times 8 is the square root of 32. And 8 times 8 times 2 is the square root of 128. And when they're entire radicals, it's very easy to see which is bigger and which is smaller. The one with the biggest radicand is the biggest number. So if I'm arranging these from greatest to least, then the biggest one is number 5. The next biggest one is going to be the 75, so it's number 2. Then it's going to be 45, so it's number 1. Then it's going to be 32, so it's number 4. And finally, it's going to be number 3. For the last example, if I'm using the Pythagorean theorem to determine the exact length of A to B, what I have here, then we should know that it's going to be c squared is equal to a squared plus b squared, where c represents the hypotenuse, which means that in this example, here would be my c, and then the a or b is interchangeable. So the first thing I'd have to do to find AB is I need to find their shared side length, which means that I can say that 12 squared is equal to 8 squared plus b squared, which means that b squared is going to equal 12 squared minus 8 squared. Well, sometimes because I have two triangles here, I'm going to wind up getting confused with the variables. So let's call this length x, just to make it easier. And then I can put into my calculator 12 squared minus 8 squared. And I'm going to say that x squared is equal to 80. So x is equal to the square root of 80. The exact value of this is the square root of 80. But that's not what I'm trying to find. I'm trying to find the length from A to B. So let's give that one a new variable. Let's call that one y. And in this case, y is the hypotenuse. So y squared is equal to the other two side lengths squared, the square root of 80 squared, plus 6 squared. Well, the square root of 80 squared actually are opposite processes. Those cancel each other out. The square root of 80 squared is just 80. And 6 squared is going to be 36, which means that y squared is going to equal 116, or y is equal to the square root of 116. Now it says that it wants it as a simplest mixed radical form, so it still wants us to simplify this. But we know that y is the same as AB, so I can say that the length of AB is equal to the square root of 116. And then I'm just going to be simplifying that 116. The only perfect square I can divide out of here is going to be 4. And I'm left with 29. Which means that AB is going to be the same as 2 root 29. Or if it wants us to do it as a decimal to the nearest hundredth, then I'm going to wind up with 10.77. And that's it.